Okay, now is the time. I will start watching the video. Here it is.
Hi, welcome to the Corp Maths Ultimate GCSE Higher Revision video. In this video we're going to go through the topics on the GCSE Higher Maths course, and the aim is to make sure you're familiar with those topics. Now, if you've got your GCSE Maths exams coming up, your GCSE Higher Maths exams coming up, this video is going to be absolutely perfect for you. Also, it's useful for anyone who wants to brush up on their maths skills. Now, this video is quite large. I spent 2 or 3 minutes going through every single topic. So rather than watching it in one go, I highly recommend you watch it in chunks and you make notes as you go through and watch the video. But also, there's an accompanying booklet, and that booklet has a question on every single topic as we go through. So that booklet can be useful to do as you're watching the video. Alternatively, you can keep it to the end of the video and then do that booklet. Now, in terms of this video, we're going to go through the topics on the GCSE Higher Revision Checklist. So this is the Corp Maths GCSE Higher Revision Checklist. And if you go to the website, there's a checklist for Edexcel, AQN, OCR. So those checklists are bespoke for each of the exam boards. And they look something like this. Now, they're pretty much identical, only a couple of subtle differences. And as we go through this video, I'll point out those subtle differences as we go through that particular topic. But there's not many of them. An example being a topic such as capture, recapture, where one exam board covers it and the other two don't. But the differences are very subtle, and I'll talk about that as we go through. So we're going to go through the topics in red to begin with. So the topics in red are the number or the ratio and proportion topics, such as standard form, limits of accuracy, proportion, reverse percentages, compound interest, topics such as those. Then we're going to go through the topics in green, which are the geometry or the shape, space and measures topics, such as trigonometry, Pythagoras, your circle theorems, vectors, topics such as those. Then we're going to go through in blue the algebra topics such as simultaneous equations, quadratics, types of graphs, and so on. And then finally, we're going to go through the topics in orange, which are the statistics or the probability topics. Now, this revision checklist is going to be really useful for you. So I've put a link to it in the description below. You may want to print it, pin it up on your wall, bring it with you on the bus. It's very important that you have that with this checklist. And this checklist has a video tutorial on every single topic. So if you want a more detailed explanation rather than the 2 or 3 minute explanation I'm going to do in every topic in this video, if you wanted a 5 or 10 minute explanation on the topic, there's the more detailed video tutorials on each one of these video numbers, and you can go to corpmaths.com and watch those. Now, as I've mentioned, I've made a booklet to accompany this video, and it's called the Ultimate GCSE Higher Revision Question Booklet. Catchy title, I know. And there's a link to it in the description below, and this booklet is going to be really useful as you watch this video. As I've said, there's a question on every single topic as we go through. There's a QR code which brings you to this video. Also, there's a QR code which brings you to the answers as well on the front of the booklet. So that booklet is going to be really useful. Now, as we go through this video, sometimes I use some of the information from the Corp Maths revision cards, and these are going to be really useful for you if you're studying free plus books.
Oh my god.
Corp Maths. I go through this first topic of the year in each of those books, and there's answers at the back of those books as well. Okay, so our first topic is adding fractions, and that's video 133 in Corp Maths. So whenever I go through this video, for every single topic we go through the explanation rather than the 2 or 3 minute explanation at corpmaths.com. And so to add fractions, it's very important that the fractions have the same denominator, a common denominator. So for instance, if we were asked to work out 2/5 plus a quarter, as you can see, the denominators, the numbers on the bottom of the fraction, aren't the same. We've got a 5 and a 4. So what we're going to do is we're going to find the lowest common multiple of 5 and 4. Well, that's going to be 20, because 5, 10, 15, 20. 4, 8, 12, 16, 20. The lowest common multiple of both of them is 20. And what we're going to do is we're going to find 2 equivalent fractions. Now remember, to find an equivalent fraction, we consider what do you multiply 5 by to get to 20? Well, that's 4. So you multiply the numerator by 4 as well. So 4 times 2 is equal to 8. So 2/5 is the same as 8/20. Next, our quarter, we want to have 20 on the denominator. So to get from 4 to 20, you multiply by 5. So you need to multiply the 1 by 5 as well. So that's going to be 5. So 1/4 is 5/20. And finally, we've got 8/20 plus 5/20. When we're adding fractions with the same denominator, we just add the numerators. So if we had 8/20 plus 5/20, that's going to be 13/20. And that's it. So 2/5 plus 1/4 is 13/20. Okay, let's have a look at our next question. So our next question is to work out 2 7/9 plus 1 2/3. So here we've got some mixed numbers, and the mixed numbers where you've got a whole number and a fraction. So for instance, 4.5. And we're going to be dealing with these mixed numbers. And whenever we're dealing with mixed numbers, whenever we're adding or subtracting or multiplying, dividing fractions, it can be very useful to turn them into top-heavy fractions. So if I just take the whole number, which is 2, and times it by the denominator, so 2 times 9 is 18, and add on the 7 is 25. So that gives me the 25/9. Next, I take the whole number, which is 1, and I do 1 times 3 is 3, and add on the numerator, which is 2. So 3 plus 2 is equal to 5, so it would be 5 thirds. So here we've written our mixed numbers as top-heavy fractions. So we want to have the same denominators. So we've got ninths and we've got thirds. So the lowest common multiple of 9 and 3 would just be 9. We could multiply both the numerator and the denominator of this fraction by 3, and that would give us 9 on the denominator. So let's do that. So we've got 25 ninths, and then we're going to add, if we multiply both of these by 3, we get, well, 5 times 3 is 15, and 3 times 3 is equal to 9. So we've got 25 ninths plus 15 ninths, and that's fantastic because they've both got the same denominator. So if we just add the numerators, 25 plus 15 is 40, so our answer would be 40 ninths. Yay. I would change this top-heavy fraction or answer into a mixed number as well. Remember, the line in a fraction means divided by, so how many 9s go into 40? Well, 4 9s is equal to 36, so it's going to be 4. And 36, well, we have 40, so our remainder would be 4. So our answer would be 4 and 4 ninths, and that's it. Our next topic is multiplying fractions. So multiplying fractions is really easy. You just need to multiply the numerators and multiply the denominators, and that's it. So if you had 2/5 times a quarter, if you multiply the numerators, 2 times 1, that's 2. And if you multiply the denominators, 5 times 4, that's 20. Now the answer here is 2/20. I'm going to cancel this down. I'm going to simplify it. We can divide both of these by 2. So our final answer would be 1/10. Okay, next we've got 1 and 1/7 multiplied by 2 thirds. Again, this is a mixed number, so let's make this a top-heavy fraction. 1 times 7 is 7, plus the 1 is 8, so 1 and 1/7 would be 8/7, and then multiplied by 2 thirds. So let's multiply the numerators, so 8 times 2 is 16, and 7 times 3 is 21. So our answer would be 16 over 21. 16 and 21 have no common factors apart from 1, and that's not going to help us. So if you want more practice on multiplying fractions, if you watch video 142 on corporate maths, you can watch the video tutorial on it, you can do some practice questions, do the textbook exercises, but also remember you've got that practice question booklet, so you can do these questions down that booklet and just make sure you're happy with this topic. Okay, let's have a look at our next topic. Our next topic is dividing fractions, which is video 134 in corporate maths. So to divide fractions, what we do is we multiply by the reciprocal of the number we're dividing by. And that sounds really complicated, but what it means is if you've got 7/15 divided by 3/4, instead of doing 7/15 divided by 3/4, what we can do is we can do 7/15 multiply by, and then we can find the reciprocal of 3/4. And the reciprocal is a fancy word for flipping it over. So instead of writing 3/4, we could write 4 thirds. Okay, so we've got 7/15 multiplied by 4 thirds. Now we've got multiply, so we can just multiply the numerators and multiply the denominators. So 7 times 4 is equal to 28, and 15 times 3 is equal to 45. So answer is 28 45ths. And apart from 1, they've got no other common factors. So that's it. Okay, our next question. Our next question is to work out 2.5 divided by 1 3/5. So we've got mixed numbers here, so let's turn them into top-heavy fractions. So 2, well, we've got 2 times 2 is 4, plus 1 is 5, so it's going to be 5 halves. And we're dividing by, well, if we look, we've got 1 3/5, so 1 times 5 is 5, plus 3 is 8, so it's going to be 8/5.
46.
Now remember, we want to multiply by the reciprocal of the number we're dividing by, so we're going to write 5 over 2 multiplied by 5 over 8.
25/16.
Next, we're going to multiply, so we've got 5 times 5 is 25, and 2 times 8 is 16. So our answer would be 25 over 16. Now, because the question is given in mixed numbers, I'm going to write this top-heavy fraction as a mixed number. So the line means divide by, so we've got 25 divided by 16. So there's 1 16 in 25, and the remainder is 9. So we've got 1 and 9/16, and that's it. Okay, let's have a look at our next topic. So our next topic is reciprocals, and that's video 145 in corporate maths. So reciprocals, we talked about that whenever we were dividing by fractions, we multiply by the reciprocal. So to find the reciprocal of a number, we flip it over. Or another way to look at it is a number multiplied by its reciprocal will always give you 1. So if we've got 5, 5 is the same as 5 wholes, 5 for 1. If we flip that over, we would get 1/5. So the reciprocal of 5 is 1/5. And if we think about it, 5 times 1/5 is equal to 1. So a number times its reciprocal is always equal to 1. So the reciprocal of 5 is 1/5. Okay, next one, find the reciprocal of a third. Well, if we find the reciprocal of a third, we flip it over, which is 3 over 1, which is just 3. So the reciprocal of 1/3 is 3. And if you just check it, a third times 3 is equal to 1. Okay, our next one. The next one says find the reciprocal of 7/10. Well, flipping it over would be 10 over 7. Alternatively, we could write this as a mixed number. So how many 7s go into 10? 1, remainder 3, 7s. So the reciprocal of 7
1/60th
tenths is 1 3/7, or 10 over 7. Okay, next we've been asked to find the reciprocal of 0.75. Well, 0.75 is equal to 3/4. So when we find its reciprocal, we flip it over, so that's going to be 4/3. So the reciprocal of 0.75 is 4/3. Or alternatively, we could write it as a mixed number, so it'd be 1, because 1 3 goes into 4, remainder 1, so 1 and 1/3. And then finally, we've been asked to find the reciprocal of 2 1/4. Now, whenever we're finding the reciprocal of a mixed number, I like to write it as a top-heavy fraction to begin with. So 2 1/4, well, 2 times 4 is equal to 8, plus 1 is 9. So it's going to be 9/4. And then if we find the reciprocal, that would be, flipping it over, 4/9. And that's it. So the reciprocal of 2 1/4 is 4/9. So we've now got multiplying decimals and dividing decimals. So multiplying decimals. Now, to multiply decimals, we can do this in two ways. We can either just ignore the decimal point and do 2,854 and multiply that by 8. And then looking at our question, we've got 1, 2, 3, 4 digits after the decimal point. So you put the decimal point in the answer, so there's 4 digits after it. Alternatively, you could multiply this number by 1,000 to get 2,854, and you can multiply this number by 10 to get 8, and then with your final answer you divide it by 1,000 and divide it by 10, and then that would give you your answer as well. Okay, so let's do 2,854 multiplied by 8 and see what we get. So 8 times 4 is equal to 32, so put the 2 down, carry the 3. 8 times 5 is 40, plus 3 is 43, so put the 3 down, carry the 4. 8 times 8, 64, plus 4, 68, so put the 8 down, carry the 6. And 8 times 2 is equal to 16, plus 6 is 22. So we've got 22,832. And to get our final answer, we can either consider the decimal places in the question. So it was 1, 2, 3, 4 digits after the decimal points in the question. So it's going to be 4 after it in the answer. So the answer will be 2.2832, like so. Alternatively, you can take this 22,832, divide it by 1,000, because you need to multiply this number by 1,000 to get a whole number. So dividing this by 1,000 would be 22.832, and then dividing it by another 10 would be 2.2832, and that's it. Okay, and our next question is dividing by decimal. So we've got 1.2 divided by 0.04. Now remember that if you have something like 6 divided by 3, that's equal to 2. And if you multiply both those numbers, the number you're dividing and the number you're dividing by, both by 10, you get 60 divided by 30. And whenever you divide that, you get 2. And if you had 600 divided by 300, you get 2, and so on. So as long as you multiply both the number you're dividing and the number you're dividing by either 10 or 100 or 1,000 or whatever, you'll always get the same answer. So if we had 1.2 divided by 0.04, I want to turn this 0.04 into a whole number. So I want to multiply it by 10 and by 10 again to get 4. So I want to multiply it by 100. So I'm going to multiply both these numbers by 100. So 1.2 times 100 is 120, and 0.04 times by 100 is equal to 4. So we're going to do 120 divided by 4, and that's equal to 30. So the answer would be 30. Okay, let's have a look at our next topic. So our next topic is fractions, decimals, and percentages. And that's videos 121 to 129 in corporate maths. So it's going to be very important that you're able to convert between fractions, decimals, and percentages. So let's have a look at these questions, and that'll help us remember how to do that. So let's change 17/20ths to decimal, and let's do that by dividing the numerator by the denominator. So to change from a fraction to a decimal, we divide the numerator by the denominator. Now we know it's going to be a decimal number, so let's put a decimal point and some zeros, and that'll help us, and just decimal point there. So how many 20s go into 1? That'll be 0, remainder 1. How many 20s go into 17? 0, remainder 17. How many 20s go into 170? Well, 8 20s would be 160, so it's going to be 8, remainder 10. And how many 20s go into 100? That would be 5. So the answer is 0.85, so 0.85. So 17/20ths is 0.85. Now let's change this decimal to a percentage. So to change from a decimal to a percentage, we just times by 100. So 0.85 multiplied by 100 would be 85, or 85%. And that's it. Okay, now we've got a decimal number. We have got 0.315, and we need to change that to a fraction, and we need to change that to a percentage. So let's change it to a percentage to begin with, because that's quite straightforward. So timesing this by 100 would be 31.5, and then we'll put percent, 31.5%. And then the change from our decimal to our fraction, I just consider what we've got. We've got 0.315. So we've got our units, or our ones. We've then got our tenths. We then got our hundredths, and then we've got our thousandths. So we've got 315 thousandths. So that's 315 thousandths. And that's it as a fraction. And then we could just cancel this down by dividing both of these by 5, would give us 63 over 200. So 0.315 would be 63 200ths. And that's it. Okay, our next one, we've got 194%. So let's write that as a fraction to begin with. So it's percent, so that means out of 100, so that's 194 out of 100. And then we can just cancel this down by halving them both, and that would give us, that's equal to 97 over 50. So 194% as a fraction would be 97/50ths. We could write this as a mixed number, so we could say how many 50s go into 97? 1, remainder 47 over 50. So we could write 97/50ths or 1 and 47/50ths. Okay, let's write our percentage as a decimal. So divide by 100 would be 1.94. So 194% would be 1.94. And finally, we're going to convert 2/11ths to a decimal and as a percentage. So 2/11ths, I've chosen this one on purpose because this isn't a terminating decimal. These are terminating decimals, decimals that stop. A recurring decimal is one that goes on forever. Or think of your third, which is 0.333333 and so on. So 2/11ths. So to change this to a decimal, we're going to divide. So let's do 2 divided by 11 and see what we get. So let's put a decimal point and some zeros, and same with our numerator, put our decimal point above. How many 11s go into 2? 0, remainder 2. How many 11s go into 20? 1, remainder 9. How many 11s go into 90? That's going to be 8, which is 88, remainder 2. How many 11s go into 20? 1, remainder 9. You can see a pattern here for me. How many 11s go into 90? 8, remainder 2. How many 11s go into 20? 1, remainder 9. And so on. How many 11s go into 90? 8, remainder 2, and so on. So you can see we're getting 0.18181818 and so on. So we could write that down, 0.181818 and so on, and put some dots to say that it just carries on like so. Or alternative, if it's a recurring decimal, we could put dots above it. So we could write 0. And then because it goes 181818, we do 1 8 and a dot above the 1 and a dot above the 8. And that just says that the 1 and the 8 repeat. So it's 0.18181818 and so on. And that's it. Okay, and as a percentage, we want to write this as a percentage. Now we had 0.181818 and so on. So we're going to times this by 100, so that'll be 18.1818 and so on percent. And that's it. So it's going to be very important that you're able to convert between your fractions, your decimals, and your percentages. Okay, our next topic. Okay, so our next topic is recurring decimals and converting recurring decimals to fractions. So let's look and see how we would do that. And that's video 96 in corporate maths. So we're going to use algebra to write this recurring decimal as a fraction. So here's our recurring decimal, 0.0262626 and so on. It could be written as 0.026 with a little dot above the 2 and a little dot above the 6. That would also be the same thing. We're going to look at how to write this as a fraction. So first of all, what we're going to do is we're going to let this be called x. So we're going to write x equals 0.0262626 and so on. Okay, so that's x. That's our recurring decimal we were given in the question. Now what we're going to do is we're going to look at our number, our 0.026262626 and so on, and look at the bit that's recurring forever. So that is our 26. It goes 26, 26, 26 and so on. So we want to find a number where we have the decimal point and then we've just got that recurring bit, 26, 26, 26, 26 and so on. Now if we multiplied this number by 10, what that would do is move all our digits one column to the left. So 10x, if we wrote down 10x, that would be equal to, if we multiply this by 10, we would get 0. And then that would be 26, 26, 26 and so on. And that's going to be really useful for us. Now what we're going to do is we want to get another number when we get 26, 26, 26, 26. So if we go back to our original number, if we multiplied this by, well, if we multiplied it by 10, that's 10x. If we multiply it by 100, we would have 2.626262. Well, that's not what we want. We want 26262626. So let's try multiplying x by 1,000. So let's write 1,000x. So if we multiply this by 1,000, we would get, well, moving all the digits 3 places to the left would give us 26.262626 and so on.
Wow.
So we multiply that by 1,000. So what we've done is we've taken our x and we've multiplied it by 10 to get 0.26262626 and so on. And we've also gone back to our x and we've multiplied it by 1,000 to get 26.26262626 and so on. Now what's really fantastic here is if we subtract these from each other, our 26.26262626, and we take away 0.26262626, the parts after the decimal point will cancel out. So let's write that down and see what we get. So let's write down our 10x and then equals 0.262626 and so on. And when we take these away from each other, we get, well, on our left hand side, we've got 1,000x take away 10x. Well, 1,000x take away 10x will be 990x. So 990x. And on our right hand side, Well, we had 26.262626, and we take away 0.262626. And if you have a look, take away 6 is 0, 2 take away 2 is 0, 6 take away 6 is 0, 2 take away 2 is 0, 6 take away 6 is 0, 2 take away 2 is 0. So we would just have, so all those numbers after the decimal point would just cancel out. So we'd just be left with 26 take away 0. And 26 take away 0 is 26. So whenever you take 26.262626 and you take 0.2626 away from that, you'll just be left with 26. So we've got 990x equals 26. Now remember, we let the number we started with in the question be x. So what we want to do is we want to solve this equation and find out what x is. So if we divide both sides of this equation by 990, we'll find x. So divide by 990 and divide by 990. And that gives us, on the left-hand side, x. And on the right-hand side, we would have 26 over 990. And that's it. So we have written our 0.0262626 as a fraction as 26 over 990, and that's it. Now we could sometimes in the question be asked to cancel it down. So if we were asked to cancel this down, well, we can see first of all both of these numbers are even, so we can divide both of them by 2. So that would give us, well, 26 divided by 2 is 13. And if we divided 990 by 2, we get 495. And then finally, 13 and 495 don't have any common factors apart from 1, so that means that that's it. We've simplified it as far as we can. And that's it. So that's how you write a recurring decimal as a fraction. So let's have a look and see how we would round numbers to two significant figures. So let's have a look at our first one. So we've got 394. So we want two significant figures. So for this number, that would mean we would want two digits and then followed by zeros. So our options would either be 390 or 400, because they are two digits, so 39 and then followed by zeros, or 400, that's 40 followed by zeros. And we would want to round it to two significant figures, so let's choose the closest one. So it's either 390 or 400, so it's going to be 390 because this is closer to 390 than it is to 400. So the answer would be 390. Or an alternative way to look at it is if we had 394 and we wanted to round this to two significant figures, well, we want to have two numbers then followed by zeros. So we look at the third significant figure, which is a 4, and that means that we round down, so it'd be 390, not 400. Okay, our next one is 1273. We want to round that to two significant figures, so we either want to have 1200 or 1300, where we've got two digits then followed by zeros. Now, as you can see, 1273 would be closer to 1300 than it is to 1200, so the answer would be 1300. Or again, we could look at the third significant figure. We've got the first two, and then the third significant figure is a 7, so we round up, so the answer would be 1300. Okay, our next one is 7,961, and we want to round that to two significant figures. So that means we want to have two digits followed by zeros. So we could either have 7,900 or 8,000, because 80 and then followed by zeros. So because this is 7,961, it's closer to 8,000 than it is to 7,900. So that means our answer would be 8,000. Or again, another way to look at it is if we want to round this to two significant figures, we look at the third significant figure, which would be a 6, and that means we round up, so it'd be 8,000. Okay, let's have a look at our next one. Our next one is 0.618, so we want to round this to two significant figures. Now remember, with decimal numbers, we ignore the 0 point and the zeros in the front, so we're just going to look at our 618, and we want to round this to two significant figures. That means we either want 0.61 or 0.62, and because it's 0.618, we're going to round it up, so it's going to be 0.62. Okay, and our last number is 20.501. We want to round this to two significant figures, so we want two digits, then followed by zeros, or if it's just a two-digit number, we just want a two-digit number. So we've got 20.501, so our choice is either going to be 20 or 21. And because it's 20.501, we're going to round up, so our answer would be 21. Or again, another way to look at it is, because we have 20.501, we look at our significant figures. Well, our first significant figure is a 2, our second significant figure is a 0, and then we look at our third significant figure, which is a 5. That means we round up, so our answer would be 21.
I need to find the best way to learn math and science.
It's brilliant.org.
Whoa.
Brilliant has thousands.
Okay, let's have a look at our next topic. So the next topic we're going to look at is use of a calculator, and that's video 352 in Quant Maths. That's very important you know where all the buttons are on your calculator that you need to know. So for instance, making sure you know where your squared is, your cubed, your power button, your square root, your cube root, your sine, your cos, your tan, and so on. Making sure you're able to convert between fractions and decimals and so on. Now, there's different calculators you could have. You could have this type of calculator that you display would look something like this. You might have a calculator where the buttons are slightly different places, but all the calculators would have the key buttons buttons you need to know, all your scientific calculators you need to
Not
have,
that
your sine,
tight.
your cos, your tan, your fraction buttons, and making sure that you're able to use them. Also, you may have a calculator that looks like this. So let's just have a look at one of these. I'm just going to use this calculator display for the minute. And this is our question. It says, work out 5 cubes, subtract the square root of 2, all divided by tan 32. So if I want to type something like this into my calculator, the first thing I would do is, because it's got a fraction, I would press the fraction button. So here, my fraction button is there, and I'd press that button, and then my display would look something like this. Next, I would type in 5 cubes, subtract the square root of 2 by pressing 5, and then the cubed button. Now, obviously, in your calculator, it might be in different places. So for me, I'd press 5, and then I'd press Shift, and then the squared button, and then that would give me the cube symbol, and then take away. And then I would press the square root of 2. And make sure you know you're familiar with your calculator and you know where those buttons are for your calculator. Then, because that's the numerator, I would then press the down button, and then I would press the tan, so tan 32. And it would look something like this. Now, with my calculator, whenever I type in tan 32, it opens the brackets, but it doesn't close the brackets. So I then make sure that I close my brackets, so it would look like this. And then I would press equals. And whenever I press equals, I get the answer 197.778613. Now, if that came up as a fraction I wanted as decimal, I would then press this button, SD, standard decimal button, and that would then write it as if it was a fraction, which convert it into a decimal for me, and that would be quite useful. Now, if we've got this calculator, what I would do is I would press the fraction button, and then I would type in my 5, and then I would press my power button, and then type in 3, and then use my arrows to then go across and then type the square root of 2. Press down to go to the denominator, press tan 32, and make sure I close brackets, and then press equals, and again my answer would be 197.778613. Now if I had a different question and my answer came up as a fraction and I wanted to write it as a decimal, for this calculator press format, and then I would press down and then press decimal, and then it would write it as a decimal for me. So instead of having the SD, the standard decimal button, it has this format button on this type of calculator, and that's it. Okay, let's have a look at our next topic. So our next topic is estimation. And sometimes in estimation questions, we're given questions like this, where we've been asked to work out an estimate for 40.18 multiplied by 6.87, all divided by 0.512. Now, whenever we're doing a question like this with estimation, it can be useful to round our numbers to one significant figure. So let's round our numbers to one significant figure. So let's start off with our first number, 40.18. So we're going to round that to one significant figure. So, but that means one digit followed by zeros. So that means that we're going to have a choice of 40 or 50. Because it's 40.18, I'm going to choose 40. It's much closer to 40 than it is to 50. Our next number, well, we've got multiply by, and then we've got 6.87. So our choices will be 6 or 7. Now 6.87 will be closer to 7 than it is to 6, so we're going to choose 7. And then finally, we've got divided by, and then we've got 0.512. We want to round this to one significant figure, so our choices will be 0.5 or 0.6. This number is closer to 0.5 because it's 0.51 than it is to 0.6, so we're going to write then 0.5. Now, whenever I round my numbers to one significant figure, obviously whenever I carry on, the answer is not going to be the exact answer. So instead of writing an equal sign here, I do this curly equal sign. It looks like this. And that means it's approximately equal to. So whenever you round your numbers, whenever you do an estimation question, you round your numbers, rather than putting an equal sign after you've round them, it can be useful to put this approximately equal to symbol. It just shows your teacher, your examiner, or even just remind yourself that you've rounded the numbers. So now what we're going to do is we're going to work this out. So we're going to work out 40 multiplied by 7. Well, 4 times 7 is 28, so 40 times 7 would be equal to 280. And then we've still got divided by 0.5. So we now just need to work out 280 divided by 0.5, and that will give us our approximate answer to this question, our estimate. And what you would do is you would just times both these numbers by 10, do 2,800 divided by 5. How many 5s are there in 2? 0, remainder 2. How many 5s are there in 28? Well, that'll be 5, remainder 3. How many 5s are there in 30? That's going to be 6. And how many 5s are there in 0? 0. So the answer is 560. So our estimate for the answer to this question would be 560. Now, it's not going to be exactly 560, unless we're very, very lucky. But that's our estimate. That's the approximate answer. Okay, so let's have a look at our next topic. So our next topic is Best Buys, which is video 210 on corporate maths. So here we've got a question, a Best Buys question that says packets of biscuits are sold in two sizes. You've got a regular box of biscuits, which has 10 biscuits for 95p, or you've got a large box of biscuits, and we've got a large box of biscuits which is 15 biscuits and it costs £1.50. And the question asks which packet of biscuits is better value for money. Now, there's two ways which I typically answer questions like this. So using the first approach, we could divide the total
Regular?
cost, the 95p, by the 10 biscuits to find the cost per biscuit. So I could do 95p divided by 10, and that would tell me how much it costs per biscuit in the regular box. So 95 divided by 10 is 9.5p. So it's 9.5p per biscuit here, per biscuit. And in the large box, it's £1.50, which is 150 pence, and that's for 15 biscuits. So you can divide a 150 for 150 pence by 15 biscuits, and that would tell us that's equal to 10p per biscuit. So 9.5p per biscuit is cheaper than 10p per biscuit, so that means that the regular box is better value for money. So that's one approach, to divide the total amount by how much you get. Another approach is to buy the same amount of biscuits by either buying just the regular boxes or the large boxes. So with the regular box, I could buy 10 biscuits, I could buy 20 biscuits, I could buy 30 biscuits by buying just regular packets. Or with the large box, I could buy 15 biscuits, or if I bought 2 packs, that'd be 15 plus 15, which is 30 biscuits. So I could buy 3 regular boxes, and that would be 30 biscuits. So that would be 3 boxes at 95p each, so 3 times 95p, which is equal to 285p, or £2.85. Or alternatively, if I was looking at just the large boxes to buy 30 biscuits, well, 30 biscuits would be 2 boxes of those, so that would be 2 lots of £1.50, and 2 lots of £1.50 is £3. So if I wanted to buy 30 biscuits, I could use the regular boxes, which are 95p each, and that would cost me £2.85. Alternatively, I could use the large boxes to buy the 30 biscuits, and that would cost me £3. So as you can see, it's better value for money to buy the regular boxes. So the regular is better value. Okay, let's have a look at our next topic, which is exchange rates or currency. And that's video 214A in corporate maths. And we're told Nicola went to Italy and she changed £800 into euros. And the exchange rate was what?
Nah, I can't make it the standard form, yo. You know what? Fuck the system! Fuck everyone! Ow! Walking in the morning, on the window. Ow! You know what? You know what? I'll be right back. I'm right back. The drums are not being played, you silly, silly fool. Whoa. 99. Oh, it's loading. That's one. Oh. Ooh, Giga chat face. Pull up, pull up. It's alright, I got it. You don't need to help. Oi! Thank you. Wait, how many? 11. Okay.
Yeah.
I don't actually want you. I don't know why I did that. I definitely don't have 10 of you, do I? Huh? Hey, dickhead. Sorry.
Yeah.
Yippee! I finally get what I've been longing for. The metal chest. Yippee. That's what I want to. Should give me a lot of XP, right? Whoa. Dickhead.
Yeah.
Um, Daisy.
Yeah. Yeah.
Handball. 17. Alright.
Yeah. Yoy. Oh. What? Yeah. Yoy. Yep. Yep. Yeah.
Damn, I did not know that's what I did. Damn pig. Oh, that's that.
Yep.
What? That's all. How do they keep getting up there? Oh gosh. Be there soon. Oh my god, I have. Thank god. What? No! Oh. Oh! Damn, it's circling. It's circling. What the fuck is this thing now?
Yep.
This is actually just going to get completely used up. Circling. Just for water. mean, I'm not opposed. Wait. You look like some people don't know.
Oh.
Place. Alright. Somebody's just stuck up there already.
Yeah. Yup.
I wonder how much it changed.
Yeah. Wow.
Soon I'll get the gun. So far. Yeah, I'll get the so far.
Oh.
Wait. Think. Wait, where do you respawn? It's strange if you ask me. One of you motherfuckers are gonna get caught.
Yep.
No, I've had enough. Had enough. Every single one I try.
What? Yoy.
Ah! I knew something like that would be up there.
Yeah. Yoy. Yeah. Yep. Yeah. Wow. Yeah. Oh. Yep. 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 Yep.
Okay.
Yeah.
Didn't realise it was that heavy.
What? What? Hip. Oh. Yoy. Yup. Oh. Wah. Oh. Yep. Yeah. Yep. Oh. Yep. Yeah. Yep. Yeah. Yup. Yep.
How do I get wheat seeds? I don't know. You know what? I don't get that wheat seeds. No. I know I said it. But get off my roof! Oh my god, oh my god, I'm going full down.
Yep. 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 Yep.
Could a pal help me out, mate? Never mind. This better be awesome. I think that's enough for today.